Welcome to the part 3 of the video. Let's go. At the board, you have the average velocity. This is where these topics start getting interesting. The average velocity is, you can see V average, or you use this symbol. Any of it you see in the table, they are the same. It just change in displacement all over time. And of course, this is what? R2 minus R1 all over T2 minus T1. Please write down this. Write down this. Jot it down immediately. Now, the instantaneous velocity, of course, is V at limit T is equals to 0, which is changing X all over changing T, which is dx all over dt. Whenever you see this dx all over dt, you know that we are talking about differentiation, calculus. And I said, check our channel immediately, go to the playlist, you see where I did a video on differentiation. Use it to refresh your memory before you come back to watch this video, unless you already have a knowledge of differentiation. Now, the speed is the magnitude of the instantaneous velocity. You can say, so it's a magnitude. Whenever I start solving calculation, you start understanding what I'm meaning, the meaning of all this. Average acceleration, this is it. Either you use A average or you use this symbol, is changing V all over changing T. Instantaneous acceleration, this is it. Now, I want to make a simple adjustment here. So if this is the formula, remember that but V here is dx all over dt. So I want to remove this V and replace it with dx all over dt. So acceleration, instantaneous acceleration will now be d. Instead of V, I will put dx all over dt, right? Remember, I also have another dt here, right? Good. So opening this bracket, this time this will give me d square x, and this time this will give me dt square. Now that's the formula for acceleration. What it means, forget the long grammar. Look at what I'm talking about. Whenever I'm talking about average velocity, you are not permitted to do differentiation. Just take the R2 minus R all over T2 minus T1. But whenever you hear instantaneous under this course, we must do differentiation. We must differentiate. And if it is instantaneous velocity, differentiate only once. If it is instantaneous acceleration, you have to differentiate. You have to differentiate it 2 times for you to solve. Now we have a beautiful question at the board here. Look at the board here. We have example number 1. The coordinate of a moving object is given by S is this. The question is A. Determine the value of S at an instant T is this. Determine if this course is very simple, but you have to be extremely careful and smart. They just said determine the value of S at an instant T is equals to 0. Solution. Let's go. Before I go to this, I forget to explain. This is position vector. R is equals to SI. That is it. Now, first of all, you have ST is equals to 9.2 minus 0.35 T cube M, right? Now, they only ask you to determine the value of S. That means wherever you see S, put 1.5. Wherever you see S, put 1.4, not 1.5. So, can you pause the video and solve it immediately? Can you? Now, so this is just X into 1.5 is equals to 9.2. There's no any S value here, so minus, there's no any T value here. Wherever you see T, replace it with 1.4. That's what it means. So, here is 0.35 into T, 1.4 raised to the power of Q. 3. So if you punch your calculator, 1.4 raised to the power of 3, whatever you get, you times it by 0.35. So, and you minus it from 9.2, your answer here is 8.2, and the SI unit is in meters. That's the answer for this one. Now, the part B is write down the position vector. The formula for position vector is xi. So look at the position vector. here R is equals to SI. Now, you have already gotten your S to be 8.2. So all you need to do is just include it I, times it with I. So this is 8.2I. And that is the answer for this. So let's continue on more examples. Example number 2 is at the board. They are giving the motion of a particle as described by this. Find the average velocity between t is equals to 1 second and t is equals to 3 seconds. Now, of course, it's still at the board. The formula for average velocity, which is v average, or you use this symbol, is still the same thing, is change in displacement all over change in time, which is r, which is r2 minus r1 and t2 minus t1. Now you can see from the question they did not give us r. Our displacement, the motion, the displacement is x here. So I can say that v average is equals to change in x all over change in t, which is equals to s2 minus x1 all over t2 minus t1. Now, all I have to do is I have to find this, and the answer will flow naturally. Now, look at our displacement at time t is equals to 18 plus 12t minus 1.2t squared. And remember I said whenever they're talking about average, whatever average, we do not differentiate. We only differentiate whenever you hear instantaneous. So here there's no differentiation. Just put first when your t is at t is equals to 1. So this is your x at t is equals to 1. So wherever you see t, you put 1 plus 12 times 1 minus 1.2, 1 raised to the power of 2. So punch it in your calculator. This should give you 18 plus 12 minus 1.2. So whatever you get as your answer should be, what you get is 28.8. So this should give you 28.8 because in meters. The next set is at t equals to 2. So wherever you see t here, so x into 2. So wherever you see t in this equation, replace it with 2. So you have 18 plus 12, 2 minus 1.2, 2 square. So if you should punch it in your calculator straight, don't want to waste much time, what you will get is 43.2. 43, what you will get here is 43.2 meters. So you have already gotten the two displacement. So put it in this formula. Put it in this formula. So from here, your x2, of course, is this, right? Your s is where your t2 is. So your x2 is 43.2 minus your x1. What we got is 28.8 all over 2 minus 1. So your V average should give you 43.2 minus 28.8 should give you 14. Oh, I made a very big mistake here. Made a very big mistake, but there's no problem. Let me just solve it like this. This is 14.4. 14. This will give you 14.4 all over 1. The mistake I noticed that I made was I gave t is equals to 3 seconds and I was using t is equals to 2 seconds. So let me just come to the question here and change t is equals to 2 seconds. So, and if t, what am I doing in this question? If t is equals to 2 seconds, this answer will change. This answer will change. Let me still put 3 seconds here. Please don't be angry. Here, every place here should be 3 because from my note is 3. So this should be at t is equals to 3. So that the answer will be uniform. So it's just that anywhere you put t, you should put 3 here, this place should be 3 instead of 2, and you still get it for 3.2. So this should be 3 minus, so here should be 14.4 divided by 2, and that should give you an answer of 7.2. That should give you an answer of 7.2 meter per second. Of course, this is velocity. Please don't be angry. If you just understand what I'm trying to teach here, this should be 3. I was using 2, so I just replaced it. I've already solved it on my notes, and so if you just put 3, that's where you will get it for 3.2. You put it in your formula and you will get this answer. Thank you very much. Let's go to the next example. Example number 3. Suppose the coordinates of an object is given by that. You have the coordinate at the board. Find the expression for Vt. Determine the value of V at t is equals to 2 seconds. What is the object speed at t is equals to 2 seconds? So, of course, the Vt they are talking about is the instantaneous velocity. If it was average, they will let you know. So this is the displacement is equals to 2.5, 8.9 t minus 1.5 t cubed, right? Now, determine the expression for Vt. That means the instantaneous velocity. If it was the average velocity, they will let you know immediately. They will tell you to get the expression for average velocity. Now, well, I told you whenever you hear instantaneous velocity, we're talking about differentiation. So here I want to differentiate. So if I want to differentiate to get the expression for Vt, so of course when you differentiate a constant under calculus is 0. And if you differentiate 8.90, what you get is 8.9 minus, here should give you 4.5 t squared. Good, that's the expression for Vt. If you don't know calculus, is on our channels, refresh your memory there. Now, the next thing is determine the value of V at t is equals to 2. So, at t is equals to 2, it means you should get the value of Vt, the value of V here. So, at V into 2, you have 8.9 minus 4.5 into 2 square. So, this is 8.9 minus 4.5 times 4. Right? So, punch it in. As usual, if you punch it in your calculator, the answer you should get is minus 9.1. So here is minus 9.1 meter per second. Now the next thing, this is the A, B, and C. Now remember, they ask you to calculate the speed, the object speed as still t is equals to 2 seconds. You already have the speed. Remember from here, the speed is the magnitude of the velocity, right? And whenever you hear magnitude, it means minus 9. The speed is equals to magnitude of V. What it means, whenever there is magnitude, if you put a minus in the magnitude, it will turn to plus. So this is magnitude of minus 9.1. The answer is 9.1 meter per second. So that is the answer. Let's go to the next example. You don't want to waste time. Of course, this should be the last one under this topic. Suppose the coordinate of an object is given by this. Find the expression for A, the velocity, B, the acceleration, C, determine acceleration, determine A, which is the acceleration, at t is equals to 1 second. So this is easy. Pause the video immediately and solve it. Do not waste time. So, of course, solution, we have to do differentiation. So this is x into t is equals to 4t plus 1.1 t cubed, right? Good. Now, for we to get the velocity, that's the instantaneous velocity. Of course, from here, we have to differentiate, which is v is dx all over dt. Now, differentiating this, of course, you have 4. This into this will give you 3.3 t squared. I'm not teaching you differentiation on this video. It's on my channel. Now, this is the expression for, this is the answer to number A. Number B, determine the acceleration. Acceleration is, the instantaneous acceleration is d square s all over dt square. So what I'm going to do is differentiate the velocity immediately. So this should give you 0 and this will give you 6.6t. This is the answer to number B. That's the answer to number B. And number C is, they want us to determine acceleration at A at t is equals to 1. So C, they want us to calculate t. So calculate acceleration at t is equals to 1. So this is the answer to acceleration. So whenever we see t, we put 1. So this will give you 6.6 times 1. So this will give you 6.6 meter per second square. So that is the answer to this example. Like I said, the differentiation is already on our channel. Endeavor to watch it. Go to our playlist, find it, watch it. Thank you very much.